All right, class, welcome. Mr. Greenwald here. Today we're going to work on perfect cubes. All right, so we already had an example where we found the volume of the last cube here was 27. You should know that by now. And that number is called a perfect cube. You can see here that it is a cube. What that means is that each of the edges are the same, right? You can see 3 across, 3 down, 3 back like that. So it's 3, 3, 3 everywhere, right? And so that's how a cube is put together. Okay, and so if the number 27 is a perfect cube, you should know by now that that is 3 cubed, or 3 to the power of 3, right? So that's what 27 is. It's 3 cubed, which is 27, and so 27 is a perfect cube. So we want to first find 4 other numbers that are perfect cubes. Well, the way you do that is you just pick a number and you cube it. So we took 3 and we cubed it by putting it to the power of 3. So we can do the same thing with some other numbers. So I figured let's start small. Let's start with 1 cubed. Okay, so 1 cubed, that's going to be 1 times 1 times 1. Well, what does that equal? That's 1. All right, so 1 is a perfect cube. All right, so let me get this back here. All right, let's think of another one here. We've got, so 1 cubed, 1 is a perfect cube. 3 cubed we've already covered. Well, let's think about 2. Let's think about the number 2. Okay, put this up a little bit here. So if we have 2 cubed, that's going to be 2 times 2 times 2. All right, so let's see, 2 times 2, here this is 4, times this last 2, that's going to be 8. Okay, so we know then that, so 1, that's a perfect cube, and we know also that 8 is a perfect cube. So 1 cubed is 1, 2 cubed is 8, and 3 cubed, that equals 27, right? Which says it right here. So the next one, I guess, would have to be 4 cubed, right? So I'll go ahead and I'll write that in this time here. 4 cubed. Okay, so that's going to be 4 times 4 times 4. Not times the dollar sign. And so 4 times 4, right here, this is 16. And then so 16 times 4, that's 64. Okay, so that means then that 64 would be another cube. And you can keep going on and on and on. You can just take whatever number you want and cube it by putting it to the power of 3, and then that will give you the perfect cube. Okay, so let's look at number 2. It says a cube has side length 4 centimeters. What is its volume? Well, you should remember from the last slide that volume equals length times width times height. All right, so if it's a cube, then that means that all of these are the same, right? So in this case, it's going to be 4 times 4 times 4. And if you look up here, we already did that. I made the dollar sign mistake as well. But so 4 times 4 times 4, we already know that that's 64, right? Okay, so volume is length times width times height. Now, most of the time, it's not going to be the same thing, right? So you're going to have to actually do the multiplication and be a little more careful there. But in this case, if it's a cube, those are all the same thing. So it's just going to be as you see right there. Okay. So a cube has side length 10 inches. What is its volume? Well, again, it's a cube. So once we know it's a cube, we know that length, width, and height, they're all the same. They're going to be 10, 10, 10. So we can just do 10 times 10 times 10. Okay? And when you're multiplying times 10, all you got to do is just multiply 1 times 1 times 1, which is 1, and then count the zeros. 1, 2, 3 zeros. 1, 2, 3, it's 1,000, right? You can think about it the other way. You can say 10 times 10 is 100, and then 100 times 10, and that's still going to be 1,000, right? So 1,000 is going to be the volume. Here, it's also worth noting that it's going to be cubic inches. And same thing up here. It's going to be cubic inches, right? Remember, with rectangles, when we find area and surface area, we're talking about square units. And for volume, it's cubic because we have 3 different numbers that we're multiplying together. Okay, and then here, so we're going to, you keep this in mind, right? Cube again, so they're all the same, and has side length of S units. What is its volume? Well, we know since it's a cube, all the sides are going to be the same, but S is not an amount. So we can't actually come up with a specific amount. We just have to use S. Okay, so we just have to say that it's going to be S times S times S. And then that's going to be, I'm actually going to write this with the pen again, that's going to be S to the power of 3. S cubed. That has to be its volume. If we ever were to find out what S is, like we knew what S was in the case of 2 and 3, well, then we can come up with a number for this one here. But until then, we have to leave it as it is. Okay,